Hello, welcome to episode 4 of the series on Introduction to Programming. In this video, we're going to cover Booleans. Booleans are values which indicate if a statement is true or false. We will often use them for logic and decision making. Previously, we talked about numbers and how we can do some math with them to uh, do various computations. Booleans are used for logic and decision making. So one of the things that you will have after this is the basics of what numbers are, text, and Booleans, and these are pretty much the main ways you do a lot of the tasks when it comes to programming. So first things first, what is a Boolean? So previously, we dealt with numbers, so we had 1 and 0. In Booleans, these are the only two values that exist, which sounds like it isn't very useful, but it actually can be very useful. The way we convey these concepts as Booleans is to say 1 is true and 0 is false. So if I run this, you're going to see that it runs true and false. When I spit out true, it spits out true, false spits out false. Now, again, that's not really useful, but the way you can make more use of this is by applying comparison operations on values to determine whether or not they are true or false. So, for example, we could say that 1 is less than 2. And we could also say that 2 is greater than 1. And if we do this, we can see that both these statements are true, right? If we check to see is 1 less than 2, well, the answer is yes. And is 2 greater than 1? The answer is also yes. So if we flip these around and we run the same code, both of them will show up as false because, again, when we ask the question, is 1 greater than 2, it evaluates to false because this is not a true statement. This is an invalid or incorrect condition. And so this is how Booleans turn more into decision making, because one of the things we can do is we can say, we can leave 1 and 2 here. For example, we can say, is x greater than y? Or is y greater than x? Again, if we run this, we'll see that x, which in our case is 1, and y, which in this case is 2, is not true, right? 1 is not greater than 2, so this returns false. But the opposite case, where y is greater than x, well, 2 is greater than 1, so that statement evaluates to true, right? So we can use these comparisons to determine whether or not a statement is true or not. And the reason why we do this is it allows programs to determine whether or not they should do something or not. I'm not going to get into branching or anything here on this particular topic. I'm going to stick strictly to what Booleans are and how we can make use of them. So what exactly can we do here? Notice how I said these are opposites. That's not really true in Boolean logic. The opposite of greater than is really saying less than or equal to. And there's a specific reason for that. So if I go and run this as is, it's going to say, well, because we said x is 1 and y is 2, I mean, the first statement is false. What is this? This is less than or equal to. And it is a way to simply state both. I'm going to get slightly out of myself, but it's the same as checking both of these at the same time. All right, what the heck is this thing down here? Well, this is simply checking, is x equivalent to y? So if I run this, you're going to get a couple outputs here. It's going to say, of course, x is not greater than y. It is going to say that x is less than y, and it's also going to say x is not equivalent to y because 1 and 2 are different values. I change these to both be the same value and we rerun this, you'll see that the first two cases, which are checking if it is greater than or if it is less than, both return false because um, a value is not less than itself and is not greater than itself, but it is equivalent to itself. Additionally, we can also do another check where we could do is not equal to or not equivalent to. And in this case, this is kind of the opposite. It's saying, hey, let's see, is X different than Y? Of course, if we run this, it will also be false. So let's change this back to 2 just to make it kind of clear what's going on here. So we can see in our original that no, 1 is not greater than Y, X is less than Y. They are not the same thing, and in fact, they are different. So you can see the outputs here changing based on how we do these comparisons and these operators that we use to determine a Boolean value. There are a few more, so I can also do greater than or equal to, and I can do less than or equal to. So I don't know about you, it is getting a little bit confusing trying to look back and be like, okay, what is X? What is Y? That is something that happens very often. And usually when you're doing comparisons or you're doing various checks, you're often going to be comparing it to some sort of known value. So in this case, I'm going to replace all the Y's with 3. Yeah, it's okay, JS Fiddle. You don't have to tell me a suggestion when I type a number. So we're going to compare all of these values to 3. I'm going to get rid of Y here because I don't need it. And when I run through this, 1 is not greater than 3. 1 is not greater than or equal to 3. 1 is less than 3. 1 is less than or equal to 3. 1 is not equivalent to 3. And again, 1 is not equivalent to 3, just actually returning a true value because that's what we're checking. One of the things you will come across, and JavaScript is a little bit loose when it comes to what is a type. And I haven't really talked about types yet, but what I can say is these are all different types. So this is a number. This is a string. This is a Boolean. Now, I haven't really used the word string, so I'm going to just say it's text. And you're probably wondering, what the heck is this thing showing up? This is called a comment. This is a way that I can type in things after these 2 slashes here, and basically JavaScript will just straight up ignore it. So again, if I go and run this, it'll run, it'll spit out, everything is happy, there's no issues. Right? I can say X equals 3 here. It's not going to do anything because comments are just simply there for the reader. They're not there for the program. They are a useful tool to help clarify, why are we saying X is 1 when you might say, well, X is 1 because 1 is the best. Not the best description, but it's kind of one of the things you could do with comments to help describe some of the things that are going on here. Personally, I would change X to something more useful, but comments can be helpful in clarifying. So in this case, let's just say this is a number. So now that I have all of these, I'm going to drop all these operators. If I say X is equal to Y, actually, it's probably best if I use 1 here. I'm going to run this. It's going to say it's true. So the number 1 is equal to the text with the value 1. This might seem like it should work. If you have used other programming languages, this probably feels really weird to see this. And that's because it doesn't care about the types. Whereas if I put 3 equal signs, and you'll see this a lot in JavaScript code, where you have either the 3 equal signs or the equivalent of not equal, which again, I can just show you here, not equal, and the famous triple not equal for JavaScript. If I run these, you're going to get a whole bunch of different answers. So yes, X and Y are loosely equal to each other, but they are not strictly equal to each other, right? The types are different between the two values. If I changed Y here to be the number one, they would actually both agree because they are the same type. But because I had this as text, if I do strict equals, which is the 3 here, it will return as false. I have to actually click the run button. So on the flip side, we have not equals. So this is, again, it's going to say, hey, these two things are, I know it's a double negative, but not equals, because when it tries to compare these two using just using the standard 2-character not equals, it first converts them to be the same type and then it compares them. Whereas when we do the strictly not equals, it doesn't do that type conversion. And so it will always evaluate as true, regardless of what values I put into here, because the types are different. Is that a problem? Not really. Usually you want to compare on the same types, which is why there is a strong preference in JavaScript when you're writing it to use the triple version instead of the double version. In fact, there's a lot of tools out there that if you get into JavaScript will simply say these are errors or warnings that you shouldn't do it. And part of the reason why is usually you don't want random text to be equal. For example, if I run this, you get this weird case where you're not quite sure whether or not these two should be equal, right? This isn't really a number, but I can compare it. So it's just one thing to note. Outside of that, you got these main operators for equivalency. We also have operators for doing our comparison. Let's highlight those again, which is we have our greater thans, we have our greater than or equal to, and we also have less than and our less than equal to. So that's a whole lot of output here. It's not very clear. You have to look at like the fifth one here, come down to the fifth one to find it. But the point is, these are the operators that you would typically use to create variables or create Boolean variables. And the reason why you would want to do this, I will get into in future topics, is to help the computers make decisions. So that is all I have for this on the topic of Booleans. Have a good day.